Now, so we can look at this example and see how they are related to each other. A golfer drives a 0.05 kilogram ball from the tee and giving the ball a horizontal speed of 40 meters per second. The contact time of the ball and the bat is 1 millisecond. We will find what is the magnitude of the average force exerted by the club on the ball during this time. And during the contact time, how far does the ball move? So something like this, you have a golf ball here, and it's 0.05 kilogram. Okay, and if you hit it and give it some speed, 40 meters per second. So you first hit it here with bat, and then it will acquire some velocity. Okay, let's put it here. Okay. So this process. So we're thinking about the heating process, not the projectile motion after that. Okay. It takes a very short time from here to here. Okay. The time interval from here to here, delta t equals to what's that? 1 milliseconds. So in seconds, what's that?
0.
Okay. 1 times 10 to the power of -3 seconds. And of course, it comes with some small delta x. Okay, so we want to find this small distance when you hit the golf ball. It's almost zero. Okay, you cannot even notice it. The time, both the time and distance are very small. And before that, we want to find the force acted on the ball during this process. So first thing, you need to make sure you know what kind of process we are talking about. Okay. Any question here? So if you look at, this is our initial time. The moment when the bat hits the ball. And this is our final time when the ball start to leave the elevated tee. Okay. So this is our initial time. So we have V naught, and here we have final V. What is our initial speed?
0.
Okay, 0. What is our final speed? 40. Okay, so please note this is 40. It's the final speed for this process. Okay. If you are thinking about some projectile motion, that's the initial speed for the projectile motion. Okay. And we try to calculate the force. Since we know the time, we can think about to use impulse momentum theorem, okay, because that involved the time. So, impulse momentum theorem says that J equals to delta P. Okay, this is a one-dimensional problem, so you don't have to worry about the vector stuff. And J, on the other hand, this gives you force multiplied by delta T. For this very short time interval, you can think about this as a constant force. Okay, so force multiplied by the time. You don't have to do the integral. On the other hand, delta P is mv minus mv naught. Okay? So, of course, you can find out the force. You have all the numbers, F, so multiply by 10 to the power of negative 3 equals to 0.05 multiplied by 40, subtract 0, okay? Initial velocity is 0, multiplied by mass, still 0. So the force equals to so this is 50 multiplied by 40, so 2,000 meters, right? Okay, so that's a force. Quite large, should be large because you hit it in a short time. Okay. Any question here?
How do you know from reading the problem that that you should use the impulse momentum theorem?
Okay, I don't really know it, but you have to try different equation. And finally, you can see this one works because this, you know, time delta t, right? So you can think about some equation involved time delta t. All the energy relationship we learned before, it will be useless here at this point, right? Because you need to know the distance, but distance is something we have to find out. So we need to find the force first. Okay, by the way, this raises a question. For this part, we already learned several energy equations. Now, we want to add some other momentum equation. How do you know which equation apply to which problem? The answer is no. You don't know. We don't know. Nobody knows. The only way is you have to do a lot of practice and familiar with yourself with all kinds of problem and situation. So then you know, okay, from my experience, I guess this particular problem, I should use a particular equation. Okay. So that's it. Theory is just theory, but theory can only be useful when you have you practice it. Okay. And also, like in the modern research, you can see that once the experimentalists find some new phenomenon, and all kinds of theorists try to explain or try that phenomenon with their own theory. And then we have to see which one is correct. So that's a similar thing. Nobody really knows which theory can be applied to that particular experimental phenomenon. And so you can only work it out and to see if it's correct. Okay. Sometimes there are two theories compete with each other for a very long time, and finally it can be verified by the further experiment. Okay. Like for example, heat. In the history, it took a long time for people to realize what is the essence of the heat. Okay. Some people try to explain heat as some kind of matter, and others try to explain heat in terms of energy. So finally we know heat is energy, not matter. Okay. But it took a long time for people to do that. In fact, initially, both of the theory works at the very early stage. You can still construct some theory of heat in terms of matter. Okay, you think about heat is some kind of invisible particle or something like that. So the heat transfer is just the movement of the particle. You still get a lot of things by that kind of theory. But finally, it turns out to be the energy theory of the heat is the correct one. So here, in fact, of course, because I have the experiments, so I immediately pick the right one equation here. But if you don't have this experience, it's okay. You just try every equation you can try and to see if it's work. Okay. So that's real life. You try every kind of possibility. But so that's why you want to do the homework. Because you want to try it before the test. You can still try it on the test, but then you will have trouble to finish your test in time, right? Okay, now. The next question, we are going to find out the distance moved by the board during this process. Okay, so how can we find the distance? Okay, so one way you can try, you think about, okay, I'm trying to calculate the distance. So can we do this? We know the distance equals to the velocity multiplied by the traveling time, right? This is some equation we know. We do know the time. Can we calculate the distance with this equation? Can we use that 40 meters per second?
No, we don't know V.
We cannot do that. Okay, what's the reason?
We don't know V.
Okay, so do we know this 40?
That's the final. 40 the whole time.
Because you can think about this is a process with changing velocity. Initially it's 0, finally it's 40. So if you want to use some velocity, you probably need to use it some velocity in between of them. Okay. But again, you cannot make sure, can we use 20? You don't know at this point. May or may not, right? Because the average for a complicated process may not be something just in between them, right? Like in the class average, the lowest one is 0, the highest one is 100, but the average may not be 50, okay, for a complicated situation. So again, here you don't really know the average velocity at this point, so you cannot use this one. But we can try to use this. W equals to delta K. Okay? Now, W is a work, so we already worked out the force. If we assume the force is constant, okay, so the work can be calculated force multiplied by delta x. So that's related to the quantity to be asked. Okay. And this will give you the change in the kinetic energy. The change in the kinetic energy will be the final kinetic energy, 1/2 mv squared. Subtract the initial kinetic energy. What's that? What's the initial kinetic energy? 0. Okay. So of course, then you get 2000 multiplied by delta x equals to 1/2 multiplied by 0.05 multiplied by the final velocity squared, 40 squared. Okay. So delta x equals to 0.05 multiplied by 1600 divided by 2 divided by 2000 equals to 0.02 meter. Okay. Please help me to check if I'm getting the right answer.
That's right.
Hmm?
That's right.
Okay. So I cannot ensure all my calculations are correct as usual. So now the distance is 0.02 meter. In fact, after that, you can try to figure out what is the average velocity during this process, right? What is the average velocity during the process? By definition, should be average velocity should be delta x divided by delta t, right? So 0.02 divided by this. So it's 20 meters per second. Okay. But you have to know this after you do the calculation. Any question here? Okay.